Hello friends, today we start new topic related to M.Sc.Sem III. The topic name is spectroscopy and its applications. This is very necessary topic and very important topic for the explanation in inorganic chemistry, organic chemistry, because by the use of spectroscopy we can identify the structure of organic compounds as well as inorganic compounds, inorganic clusters, elucidate the structures by the following data. Therefore, the spectroscopy have very broad area in education field as well as pharmaceutical industries as well as in medical point of view, because the spectroscopy used for identifying proteins structure, MRI, etc., organic compounds structures, and in the pharmaceutical industries, the drug synthesis in which the drug synthesized, in which the drug synthesis, the structure of the compound, and this compound is formed or not after the reaction, we can identify easily. We can interpret the structure, interpret the product after the completion of the reaction by the use of spectroscopy. In the examination point of view, the spectroscopy is very important because the 20 to 15% questions asked in different competition exams like NET, first grade, and any chemistry related exams, the 10 to 15% questions asked in particular this topic. Therefore, it became a very important for all the students. We will take this topics step by step. First of all, what is the spectroscopy? Before the studying the spectroscopy, we will discuss about electromagnetic radiation, because the spectroscopy is mainly based on EM, electromagnetic radiation. Spectro means spectra, spectrum. So what is the spectrum and what is spectra? What is spectroscopy? What is the feature of spectroscopy? What is the features of spectroscopy? We will be studied in incoming slides. First of all, we will discuss about what is spectroscopy and electromagnetic radiations. In the spectroscopy, we will use in this incoming slides, that is the slides we will show here, property of the electromagnetic radiation. And first of all, what is the electromagnetic radiations? The electromagnetic radiations, electromagnetic light, is collectively called incoming the sunlight radiation. First of all, what is the spectroscopy? The spectroscopy is a method of analysis based on the interaction, absorption, transmittance, or production of the light by matter, and scattering of the matter, scattering light by the matters. We will study first of all electromagnetic radiations before the studying of the spectroscopy. The electromagnetic radiations is divided in two views. First of all, wave model. The wave model is discussed here. This is the crust and rough amplitudes there. The electromagnetic radiations propagated in wave nature, like the sunlight we absorb in our environment, in which the wave model represented by sinusoidal wave traveling in space with an oscillating electric field and perpendicular magnetic field, like this, like this. Perpendicular propagation direction के perpendicular magnetic field, electric field, perpendicular to each other. The electric field is what is considered or used in most spectroscopy methods. You know that the electric field is what is considered as most of the spectroscopy methods, exception NMR. Because NMR use radio wave and with magnetic fields also. Descriptions of wave model: amplitude, we can calculate the amplitude of the wavelength, and descriptions of the frequency, velocity of the propagation, and in the particle model we discuss light as used as discrete particles of energy. This is called photons. Like other particles, light can be scattered, countered, and quantized. Therefore, the photons collide with matters, in which the matter's energies goes from low to high. The energy difference between the two levels is denoted by this formula, and the energy wave or particles is calculated by this formula. It is known as E is equal to h nu, where the nu is equal to frequency. This is the h is a constant, frequency, lambda, or wave number. We know about this. Now we will discuss here in the next slide what is spectrum. What is spectrum? The spectrum is defined as the characteristic wavelength of electromagnetic radiation that is emitted or absorbed by an object or matter or atom or molecules. The spectrum is single, but spectra is plural, singular and plural. Okay? The examples of the spectrum include the rainbow, the emissions color from the sun, and the infrared absorption wavelength from a molecules. Now friends and my dear students, we will discuss the electromagnetic nature, the type of the electromagnetic nature, in which all of the small fractions The complete variations of electromagnetic radiation is used throughout the spectroscopy. Complete variations we used, varieties of variations used. Different energies allow monitoring of different types of interaction with the matter. डिफरेंट एनर्जी जो होती है इस इलेक्ट्रोमैग्नेटिक डिफरेंट डिफरेंट एनर्जी से मैटर के साथ में इंटरेक्शन जो होता है वो डिफरेंट डिफरेंट पॉइंट ऑफ व्यू से होता है, उसको डिफरेंट मॉनिटर किया जाता है, उसके अकॉर्डिंग हम उसके बारे में पता लगा सकते हैं. ओके, therefore we will focus on the separations and types of the wide range of the types of the electromagnetic radiations. Types of the electron. First of all, it is divided into radio waves. Its energy is lower in the all of the radiations. In which all of the radiations. Second is microwave. Third is far IR. Fourth is mid IR. Near IR. We will take a marker. Near IR. Visible IR. Color change, and we will want to blue color for clearly show this diagram, this range according to the slides. Visible, near UV, vacuum UV, X-rays and gamma rays. लास्ट में कॉस्मिक रेज आता है, उसका मैं अभी इस जरूरत नहीं है. तो रेडियो वेव से संबंधित जो न्यूक्लियर स्पिन ट्रांजिशंस NMR related to radio waves. The NMR spectroscopy related to radio waves. In rotational spectroscopy related to microwave. In infrared spectroscopy, IR spectroscopy related to far IR. And visible and UV electrolytic spectra is created by UV and visible. This is called UV spectroscopy. And X-ray diffraction, X-ray spectroscopy. Now we will clearly shows that this electromagnetic radiations work on the base of energy level in spectroscopy, because the energy of the different types of electromagnetic radiations conducted, its phenomena, its for the matters are different. Therefore we detected this different type of attraction, deflection, absorption, interference and transmittance of these lights. We will detect the spectroscopic matter by electromagnetic radiations. What happened, what type of nature change in electromagnetic radiations we will absorb, we will detect this different or difference previous electromagnetic radiations, or after applying this radiations on the matter, we will detect it by different spectroscopic technical instruments, and we will discuss here one by one this type of spectroscopy. Therefore, we'll now in the other lecture we will discuss about this spectroscopy by one. Thank you so much.